Alright, today we are talking about simplifying radicals still, but this time we're going to throw in our variables with some exponents. So, we're going to write out for this first example what x cubed means. That means x times x times x, and these are all in my root, by the way. My y to the fifth, that stands for y times y times y times y times y, and my z to the 12th, ooh, that's going to be 12 of them. I'm just going to put them in a row down here, but they're all under my radical. So I've got 3 of those, 4, 5, 6, 7, 8, 9, 10, 11, 12 of them. Don't worry, you're not going to write these out every single time, just this one example. Alright, so if it's a square root, remember, to get outside of this radical, to be on this outside, this coefficient, you've got to have 2 of a kind, square, 2. If you're inside, then you did not have 2, you just had 1. So let's try it out. Of my x's, I had a pair of x's, get out. Alright, but this little x had to stay inside. Then for my y's, I had a pair of y's, so it goes outside. Wait, I have another pair of y's, so there's another y out there. And then this lonely y stays inside. So let's try out my z's. I had a pair of z's. I'm running out of space here. I'm going to put them down here. Another pair of z's. Another pair of z's. Another pair of z's. Another pair of z's. And another pair of z's. So all of my z's got out of my radical. Now I don't want to write it like this. This is a mess. So what I should write instead is I have an x. I have 2 y's, I have 6 z's, and what I wasn't able to get out was an x and a y. So that would be my final answer. Now, without showing all this work, you could have gotten that same answer too. Let's take a look. Let's look at my exponents. They're telling me how many x's I have, how many y's, and how many z's. So if I have 3 x's, I have a pair of x's with 1 left over. If I have 5 y's, I have 2 pairs of y's with 1 left over. If I have 12 z's, I have 6 pairs of z's with none left over. So what we're really doing is we're dividing by 2 each time to get to the outside. And any remainders would go inside. So let's try that trick instead of writing everything out for my second example over here. Same variables with exponents, but I'm doing a cube root. So square roots is 2, cube roots is 3 of a kind. So how many triples do I have in x cubed? I have, well, just 1 triple. Give yourself some space there. For y to the 5th, I have 3 of a kind, 1 time, and then 2 left over. And then for z to the 12th, how many times does 3 go into that? Well, 4 times. So z to the 4th, and that goes in evenly, so no left over. So my final answer is right there, x, y, z to the 4th, cube root, y squared. So for these next couple examples, I'm just going to combine what we did with the numbers and what we are learning about these exponents here, these variables. So when I see 19, first off, it's a square root, so I'm looking for pairs. Let's see what goes into 18. 9 and 2, and 3 and 3. So I've got, in this radical here, this square root, I have a 3 with a partner that gets to escape. Give yourself a little room, because I also have an x squared. I have a pair of x's that gets to escape. But inside the radical, I've got a lonely old 2. So final answer is 3x root 2. So again, the reason I have 1 x out here is because x squared stands for 2 x's, so a pair got to get out. Alright, another square root over here. Let's see what we've got. So 8 is 4 and 2, which is 2 and 2. So let me go get my root ready to go. On the outside, I've got a pair of 2's with a 2 left over. And for my variables, I've got 2 x's and a y. So an x gets to go out, none left over, with a y still inside. So 2x root 2y. Alright, let's try this next one. It is a cube root, so we're looking for 3 of a kind. I've got 4 times 3 and 2 times 2. And I am looking again for 3 of a kind. I don't have 3 of a kind this time. So actually nothing gets to escape from my 12. all of it is still back inside. Nothing gets to escape. But let's check out my x to the fourth. I have 3 of a kind there with 1 left over when I have 4. Again, if you need to see a picture of that, you can draw it out. 3 of a kind with 1 left over. So that is x cube root 12x. Didn't seem like we could do much there. Alright, last example. 8. So I'm going to say 4 and 2. And then I've got 2 and 2. So I've got 3... Sorry about that. I've got 3 2's right here. So it gets out of my cube root. So I've got a 2 out there. And then my y, if I have 6 of those, I have 2 groups of 3. So I've got 2 groups of 3. Wait, I don't have anything left over. I've used everything. Because none of this exists. I've used it all. So this is a case where we had a perfect cube. We didn't realize it at first. You don't need anything in the radical. You don't have to have it there. It's just 2y squared, no root. And you're done.